Hey everybody, I'm Tom Tullis. This is the Tomb of 3D Printed Horrors, and today we're going to talk about under extrusion. Now, this is something we all experience at some point. It's not just when you go to Taco Bell too often. Anytime you're printing with an FDM 3D printer, you run the risk of having under extrusion. The thing that's really frustrating about this is if you ask 10 people what's going on, you're going to get 10 different answers. And the reason is there's more than 10 causes for it. So what we're going to do is walk through each one step by step. So hopefully you can better understand what's going on and troubleshoot any issues with your 3D printer. Let's start with how to identify under extrusion. What does it look like? Well, in most cases, under extrusion is going to look like this. It's going to have missing plastic in the sides of the model. You're going to have gaps in layers. Those are the areas where the plastic did not extrude properly for one of a host of reasons, and you just have a gap. Now, under extrusion can also present itself as a brittle model. Maybe there's no gaps at all in it, but due to the under extrusion, the individual layers did not properly bond together, and you can literally pry the model apart with your bare hands layer by layer. Both of those are under extrusion. The most common issue or common cause of under extrusion on a 3D printer is temperature. You're printing too fast for the temperature you're melting your plastic at, and it can't fully melt in time to extrude, so it has under extrusion. How do you fix it? Well, two things. One, you can up your temperature. Two, you can decrease your print speed, or you can have a combination of the two. Now, this is critical. When you up your temperature, only do it in 5-degree increments. You can very rapidly go from under extrusion caused by too low of a temperature to under extrusion caused by too high of a temperature. What's the difference? Well, at too low of a temperature, the plastic is not fully melting. So it can't go through the nozzle, therefore nothing comes out, and you have under extrusion. When you have too high of a temperature, you get heat creep going up the length of the hot end into the areas that should be cool. The plastic, where it should be solid, starts to deform. It's reached its glass transition temperature and it bulges. That causes drag and it can't be pushed cleanly through the system, resulting in less filament coming out and under extrusion. So again, if you're adjusting your temperature, go in 5-degree increments. It'll make it much easier to identify that sweet spot. A lot of times you have a roll that printed great for a while and then it starts having under extrusion. What's going on is that roll has absorbed moisture. That's affecting the temperature at which it will effectively melt. So it's very common to raise the temperature 5 or 10 degrees by the end of the roll if you've had it for a while than what you started out printing at. So just be aware of that. Watch out for your temperatures and speeds. Now, almost as common is simply the filament snagging up before it feeds into the system. If you've taken your filament on and off of your printer a few times and you've let that end flap up into the spool, it's very easy for the end to get under another wind of the filament and it snags. So you always want to tape that loose end of the filament to the edge of the roll or one of the side little holes you can snake it through so it doesn't work under the other filament loops. If it has, you're going to have to untangle it because it's just going to keep tangling up every few turns and causing binding and drag and under extrusion for you. So that's a very common cause of under extrusion for you on these printers. Now, on down towards the extruder, if you have any kind of filament guides, make sure the filament is feeding cleanly through them. If they're not, that could be a snag and that could be holding you up. Specifically on the Creality Ender 3, the filament guide on the extruder, where the little lever is that you squeeze on the spring, that is made of plastic. And in just a matter of weeks or even a month or two, the hole in that plastic can wear from being a hole to being more of a triangle shape from that filament rubbing through it, and it erodes down. It will start snagging and causing under extrusion on you. That's why I recommend in my Creality 3 build video replacing that out with an aluminum extruder. I have that linked in the product description or in the video description here for this video, but it's just 4 screws. You can change it out in about 5 minutes and it's really worth doing. You're going to have to do it at some point with the Ender 3 because that plastic lever will not last very long. So snagging is another common issue. Just look for places along that filament path that it could be hanging up. Another cause of underextrusion that people overlook very easily is the slicer. Sometimes you can get the wrong filament diameter listed in the slicer for slicing your models. This just happened recently with Cura 3.5. In Cura 3.5, the Ender 3 profile had the filament diameter set to 2.75 millimeter when it in fact uses 1.75 millimeter filament. This caused the slicer to think for every millimeter of filament that was being pushed through the system, almost a third more filament was actually being gone through than what was, which resulted in underextrusion. So make sure your slicer filament settings, the diameter you have set, matches the diameter of filament that your printer actually uses. Again, it's really easy to overlook this, and you can get really frustrated looking for a mechanical issue when in fact it's a software issue. Next, bed leveling. If you try to print your first layer too thin, in other words, your nozzle is too close to the bed, the amount of filament that's supposed to be coming out can't, and it starts backing up, and that creates a partial clog. Heat creep will go up the length of the filament, and it will swell, and that will cause drag. So check your first layer, check the skirt that printed around it. If that skirt doesn't feel like fishing line, if it feels completely flat, you're too close to the bed, you need to re-level your bed, and that will resolve your extrusion issue. Now, filament feed gear on your extruder. That gear with those teeth that grips the filament. If that clogs, if it gets a lot of plastic shavings in it, it can no longer grip the filament for feeding through the system, and that can also result in underextrusion. Now, related to this, if that's clogged, it's a good bet that you have plastic shavings in your Bowden tube as well if you have a Bowden tube feed system. So you can clean the filament gear. First, take your filament out of the system, clean the filament gear with an old toothbrush. If it looks like you have plastic shavings down in your Bowden tube, if it's a Bowden tube system and not a direct system, what you can do is simply take the Bowden tube out of your printer and use some compressed air to blow any shavings out, and that should resolve it. For me, Bowden tube is so cheap, it's only about $1 for the length necessary on like an Ender 3. I would just put a fresh one on and be done with it. But if you want to try cleaning it, you can just use compressed air and that should work. Now, also on the extruder gear, most printers have an adjustable spring tension for that feed gear. If you have too loose of tension on it, it's not going to grip that filament tightly enough to feed through your system. What you have to do is there will be a small screw or screws that will actually tighten down or loosen on that spring to add more spring tension on those feed wheels. Check that, make sure it's gripping tight enough. If not, you can adjust it. Now, unfortunately, if you've got like an Ender 3 or a CR10, you can't do that. It's not adjustable. The spring is always at full force. If that still isn't enough, what you can do is shim it. You can put small washers or shim stock in here between the extruder and the spring, which will compress that spring more and put more tension on the feed wheels. It's a really easy fix. Just get some washers that will fit over that screw, take it out, put the washers on and put your screw back in, and that's all you need to do. Just get a few thin washers and put them on one at a time until you get good reliable extrusion. You don't want to put too much tension on it because that's going to make the feeder gear dig too tightly into the filament, and that's going to grind it down, especially on retractions, which we're going to talk about next. Now, if you have under extrusion in an area of your model that is highly detailed and has a whole bunch of retractions, it could be you have your retraction number set too high. Now remember, your feeder gear, when it retracts, it's pulling that filament back and forth over that gear. Every time that gear contacts that filament, it's grinding it down some, it's digging into it. So the longer the length of retraction, the more times that feeder gear is going to pass over any given point of that filament during the retraction process. If you have a whole bunch of retractions in one area of your model, that can grind that filament down to the point it can no longer reliably grab it. So how do you fix this? Well, there's two issues here. In both cases, what you're wanting to do is reduce grinding on the filament. The first way you do that is adjust your tension on the feed gear. You want it tight enough that it can properly grip the filament to feed it reliably, but not too tight to where it's actually grinding it down and creating a gap. So you've got to find that sweet spot. If it's too tight, it's going to grind that filament down and cause underextrusion. If it's too loose, it's not going to grip the filament tight enough to feed it, and you're going to have underextrusion again. So you've got to find that sweet spot where it's just barely making an indentation in the side of the plastic, but not too deep of a one. And this is something you're just going to have to develop a feel for. Basically, what you want to be able to do is on sections of filament that have already run through the extruder, run your finger along them. You should be able to feel the dig in the side of the filament from the feeder gear, but it shouldn't be too deep. And again, it's something you're just going to have to play around with. Now, the other thing you can do to help alleviate this is reduce the length of your retractions. Having a retraction that's like 8 or 9 millimeters is way too much. For me, on an Ender 3, my retractions are usually set around 5 millimeters. 6 millimeters wouldn't be bad, but anything beyond that is going to start, because of the usual amounts where you start having in detail models lots of retractions in a certain area, you're going to be going over the same length of filament again and again and again and wearing it down. So try to get that retraction length down as low as you can without inducing stringing, but you really don't want it much over 6. Now, this next one is more particular to the Creality series of printers, the Enders and the CR10s. On these printers, the Bowden tube goes all the way through the heat sink, through the heat block, or through the heat break into the heat block. That Bowden tube then meets up with the back of your nozzle. Now, they should fit tight so that your filament goes straight from the Bowden tube into the nozzle. What happens with these printers is Creality uses a very poor quality connector that locks the Bowden tube into the hot end. It's just a little screw piece. They're about 50 cents online. I've got them linked in this video to put a better one on. In my Ender 3 build video, I actually recommend that's the first thing you do is replace those pneumatic couplers for the Bowden tube. The ones that come from Creality are crap. They will fail. Sometimes in a matter of just a few weeks, they're going to fail. What does that mean? Well, when that clip fails, when the teeth start breaking off, your Bowden tube is going to separate. When you have a retraction, it's going to get yanked up with that filament away from the nozzle. That creates a gap. That gap is going to get filled with softened molten plastic. When that happens, that plastic that fills that void is going to start causing drag on the filament that's feeding through the system, and that causes your underextrusion. It will also create issues with your retractions, making them less effective too and result in more stringing. So as I mentioned earlier, if you're seeing increased stringing on your model and underextrusion, the problem is your Bowden tube has separated from your nozzle. And what you're going to have to do is take the heat it up, take the filament out, take the Bowden tube out, take your nozzle off, clean all that out, and then reassemble it. I have a nozzle changing video on this channel that I'll walk you through the whole process. It's not hard, but we've already covered it there, so I'm not going to go through the process here. But that's your problem. You'll have to clean out that molten plastic. A really easy way to do that is when you get it all apart while it's heated, you can just stick a toothpick down there. It won't harm the aluminum on the inside, but it's enough to pick off the plastic and get it cleaned out to reassemble. Okay, this is for Ender 3 owners and some of the other Creality printers that use the same hot end. The factory that assembled these hot ends made a mistake. They left the 2 alignment screws, shown here on the left and right on each side of the heat break, in when they assembled the unit. These screws were meant to be taken out when the hot end was done and the printer was assembled. They weren't. And they even applied the insulation over the heater block over the screw heads. So you can't back them out without having to remove that insulation. So what do you do? Should you remove these? Well, I have several Ender 3s and I have not removed mine because I've not seen any issues with underextrusion. If I ever do, I will take them out at that point. But for me, it's a case of if it's not broken, don't fix it. Now, if you are having issues with underextrusion, it could be from this. What's happening is heat from the heat block is transferring up those screws into the heat sink. That's the part in red with the individual fins for cooling. When that area heats up, it's meant to be room temperature. When it heats up, it can cause the filament inside of it to reach its glass transition point and soften slightly. As you do retractions, it's going to stretch that filament out. When it pushes it back in, it's going to deform it. That is going to cause additional drag, which can cause underextrusion. It can also create a clog. So, as I said, I've not seen any evidence of this with mine. I've left mine in. If you want to take yours out, go look at my video on this channel for replacing nozzles. I take you through the whole process of how to remove the insulation from the heater block. At that point, you can remove the 2 screws, and then you're going to have to install replacement insulation. What I show you in that video is how to put on a silicone sock over the heater block to replace the factory insulation that you have to remove to get these screws out. So I'm not going to cover all that here. That's all been covered already in the nozzle change video. You can go check that out if you want to take these screws out. Now, one other issue with Bowden tubes is when you get down to the end of the roll of filament and the filament is more tightly curled, that can cause problems if you have a Bowden tube feed system, because that tighter curl is trying to run through a straight tube, and that's causing drag. That's going to cause potentially some underextrusion. So if you've been printing fine and all of a sudden you're at the end of your roll and you're seeing the underextrusion, try on taking the filament off the roll, straightening it out a little bit, and seeing if that resolves it. Odds are it will. Now, the final cause, or I shouldn't say final, there's others, but the final of the more common causes of underextrusion is a partial or fully clogged nozzle or hot end. How do you tell? Well, what you want to do is preheat your hot end up. Do it to 210, 215. Release the tension on your extruder. In the case of the Under 3, you just squeeze this arm in so you can manually push the filament through the system. If it comes out cleanly through the nozzle, straight line coming straight down, no problem, you don't have a clog. If it comes out as a thinner line that wants to curl up just on the end of the nozzle, then you have a partial clog. And I'm going to tell you how to fix that. What we're going to do is called a cold pull. And I hate this term because it's misleading. Every time I tell people they need to do a cold pull, they think they're doing a room temperature pull and try yanking their filament out. That's not it. This pull is actually done while heated, just not heated enough to melt the filament. So what you're going to do, if you have a Bowden tube feed system, you want to remove the plastic from the system, heat the nozzle up, remove your plastic filament, then remove the Bowden tube. You do not want to feed the plastic through the Bowden tube for the cold pull. If you don't have a Bowden tube system, all you got to do is release the tension on your extruder feeder and manually insert a length of filament. Cut a piece of filament about 1 foot long. You're going to manually insert it down while the hot end is heated to 210 or 215 into the nozzle. You're going to force it in there until you see it come out of that nozzle, or if you can't get it to come out, as far as you can. Then on your LCD screen, on your temperature control, you're going to dial that down to 90 degrees. What's that going to do? Well, as the temperature drops, the plastic in that nozzle is going to solidify, but it's not going to be totally hard. If it's kept at 90 degrees, it is above its glass transition point. It's still going to be slightly soft. When that temperature hits 90, you're going to give a sharp yank up on that filament and then look at the end. If it's clean, you didn't have a partial clog. If it has little bits of dirt in it or darker debris, what that is charred filament that started blocking it. So what I want you to do is, if you had that on the end, that charred filament, that darkened areas, cut yourself another section of filament, reheat the system up to 210, 215, feed that filament in, put it down to 90, and do another cold pull. Keep doing that until your filament comes out clean, and then you know the nozzle is clean. Reassemble your Bowden tube if you had it, and you're done. If you need to change the nozzle, if it's too bad clogged and you can't do a cold pull to fix it, then you need to look at my nozzle changing video, and it will walk you through step by step how to put a fresh nozzle on your hot end. Okay, so that's it. That is pretty much all of the causes of, or the more common causes, I should say, of underextrusion on an FDM 3D printer. Now, please click that subscribe button on your bottom right-hand corner. We've got something really cool coming up for subscribers in a few months, and you don't want to miss out by not being subscribed. Also, if you have any questions, I'll be happy to answer them. You can post comments here in the video, Or better yet, join us over on Facebook in our Dragon Lock Facebook group. We do troubleshooting there every day to help people get their systems back online, get better prints. We would love to have you join up. The link is in the video description. So thank you for checking this out. I'll see y'all next week. We're going to have a video painting tutorial next week.